So now let's talk about an example of multiple regression. And for this, we're going to turn back to our Cortina et al. 2000 article and what they found about predicting job performance from cognitive ability, from conscientiousness, and other factors. And they talked also about structured interviews. But where we started with when we talked about bivariate regression was a simple bivariate regression model in which job performance, remember this was a standardized regression model, job performance is equal to 0.432 times cognitive ability. Now, remember, because this is a standardized regression equation, this 0.432 gives us the standardized relationship between the z-values, the z-scores of cognitive ability, and the z-scores of job performance. Now, we don't typically see it written that way in the results section. We'll see it something like this. Job performance equals 0.432 times cognitive ability. And then it'll say in a caption or another note, this is a standardized regression equation. And because we know it's standardized, we know that means we're talking about z-scores. And that means that our interpretation then is that for every standard deviation shift in cognitive ability, I have a 0.432 standard deviation shift in job performance. Right? And so I know that's a thing. Now, let's say this, cognitive ability is not the only predictor out there. It's a good predictor in the sense that it's very predictive of job performance, but there's a lot of issues with it. And you never want to use cognitive ability by itself, not the least of which because it causes problems with adverse impact. So we look for other predictors as well that can be that create a better overall model of how we might predict job performance. So in Cortina et al., they said, okay, here's the relationship for cognitive ability. What if we add conscientiousness to this, right? And conscientiousness is a personality dimension from the Big Five. It refers to someone's goal striving, their sense of duty, their desire to do well, their achievement striving, their sense of organization. All these things lead to conscientiousness. So you can see logically why that would predict job performance. So the question, though, isn't does it predict job performance? Does it predict job performance over and above cognitive ability? Right? It's not even does it predict it better than cognitive ability. It's let's start with cognitive ability and let's see if conscientiousness adds to our predictive ability. And what they found is that job performance can be predicted by cognitive ability, 0.432 times cognitive ability, and again, this is a standardized equation, plus 0.235 times conscientiousness, right? And so now we have these two partial change rates. For a holding conscientiousness constant, for a single standard deviation increase in cognitive ability, we get a 0.432 standard deviation increase in job performance. Likewise, holding cognitive ability constant, we get for every single standard deviation shift in conscientiousness, we see a 0.235 standard deviation shift in job performance. So if we're going to compare the two, and we can, cognitive ability is a better predictor than conscientiousness. But that doesn't answer the question at hand. The question is, does conscientiousness add anything to what we're trying to accomplish? Does it add to our predictive model? And we can't get that straight from these numbers. Where we get that is an additional statistic called the change in R squared. So if you'll remember, the R squared here for this initial bivariate model was let me make sure I get it right, 0.187. Right, so 18% of the variance in job performance explained by cognitive ability. The R squared for this model was 0.257. 257. Right, so now we're saying that almost 26% of the variance in job performance can be explained by cognitive ability and conscientiousness together. Right, and so now we see this increase. Instead of just 18%, of the variance in job performance, we can now explain nearly 26% of the variance in job performance. And so the delta R squared, which is 0.257, this R squared of our second model, minus 0.187, the R squared of my first model, is equal to 0.07. So I had an additional 7% of the variance in job performance is explained by adding in conscientiousness to my predictive model, right? And so as long as this value, the delta R squared, and again, in some of the older articles, you might see a delta F, but typically today we see a delta R squared. As long as that delta R squared is greater than 0, then we say that our additional predictor is valuable, that it adds to the predictive model. Now, there are adjusted R squareds, and there's reasons for doing that, and we'll get to those later on, probably next week or the week after. We'll talk about some caveats to all this. But what I want you to understand right now is this idea that as we add predictors to the model, we want to consider, does it make the model better? And if it increases the R squared, if we have a positive delta R squared, then it's making the model better, and it's okay to include it. Again, there's some caveats to that. We'll talk about those. But for now, just get this idea. Now, how is this reported? About a gazillion different ways, right? And so it depends on the article. This is usually called, in the book, it's called a stepwise, I think, or a step-by-step method, or step method. I've seen it stepwise. Sometimes called hierarchical linear modeling. Hierarchical regression analysis is how you often see it. And so there's lots of different things to call it. There's lots of different ways to report it. But we'll see this over and over again in various articles. So I want to show that real quick. Typically what you'll have is some sort of table, right? And the table is usually going to have maybe across the top, it'll say our beta weights, and then it'll have maybe it'll have a t or something associated with that beta weight. So that's a t gives us, we could do t-tests around individual beta weights. That tells us the probability that beta weight is something other than 0. So that's a useful thing. It's good for hypothesis testing. So it might give us the beta weight, and it'll give us maybe the t as well, and then it'll tell us the R squared of the model, and it might even have the delta R squared. Now, for the Cortina et al., I probably should, but I don't have in front of me what the t values were, so I'm going to ignore that for the moment, right? I'm just going to say the R squared and the delta R squared. So that's the top of the table, right? And then it'll say models, because we don't leave this part blank. And then it'll say step 1. And this is typically how this works. So step 1, it'll say cognitive ability. Right, and here it'll say 0.432, 0.187, and then a null, right? Because this isn't a change yet. And then it'll say, in the second step, right? So the wording would say something like, in the second step, we added conscientiousness to our equation. So here it'll say cognitive ability, conscientiousness, and it'll say, these were our results, 0.432, 0.257, right? Gave us an R squared here of, what did I say the total was? 0.257, right? And a delta R squared of 0.07. Now, the reason you would want to report this again is that oftentimes this number will change. For various reasons, in this particular model, it doesn't change, and it's kind of, I'll hand wave that for the moment. It kind of doesn't matter for our discussion right now. But this is going to often change as we add additional predictors. Our partial change rates are going to change as well. So we'll report them again, right? And so here we have, in the first regression model, these were our results. And then when we added a second variable, these were the results of the regression model. And then we can draw a conclusion here that because our delta R squared here is positive, it's 0.07, that adding this second predictor variable is useful and has what we call, this will be called incremental validity. In other words, it is predictive of job performance over and above cognitive ability alone. So that's an important part of multiple regression, and our interpretation of multiple regression is understanding that hierarchical step process.